Welcome back everybody, good to see you. It has been a while, new job, but I haven't been doing nothing. I've been working on the speedometer from last time, and now look at what I made with my amoled S3 controller. Let me plug it in. Here we go. And we have a pretty cool dashboard, right? Now let me rotate the wheels. I put you see the rear of the car on the edge, so it's the wheels are in the air, so it's not going to move. And if I start running, you see the speed changing. I can also reverse, of course, and the speedometer also shows that, because simply it can't really distinguish which direction it's moving. There are some other features. I have, of course, the blinkers that are now also reflected in the dashboard. And in the other blinker, I have the alarm lights. And I have the low beam and high beam. So it's a pretty complete dashboard, and I like it. So let's see how we got here.
What we're going to be
doing first of all, a bit of a shout out to Volos, which is a channel that does
JPEG, a bitmap, and how to convert it into
ESP32
or C++
on Arduino.
byte array
usually
code that will tell us exactly what
so
each
that was
pixel
really
color
valuable
needs
to
to
me.
be.
Yo, so if you see this design, you
this.
see
There's
where I got it from. So he got it from somewhere else anyway, but still,
images
I think he's a really nice channel, and I'm really terrible
But ultimately what we're going to do is we're going to take two images, the image of the gauge, the image of a needle, we're going to deposit them together in a string, and we're going to have a
local toy to play with, just to
some benefits to
just to as a demo, which I really appreciated.
And also some things that we should watch out for.
Design from another
to get started,
other user. So pretty nice.
Instead, we need to talk about the process of
don't have the
images.
Yeah, this is the
now,
source
in the
he
description
got
of the
it
video,
from.
there are a couple of links.
So yeah,
the first one is an image
design
to
goes all the way back.
CPP.
But
yeah,
for
web browser, but you
I
can
don't have the
download
exact
this and use
same
it
microcontroller. I have the S3
and it
AMOLED, and
fine.
he is using the
Now, this is a
regular
great tool, and it works
LED
pretty
one.
well. It
And I
has
thought that
some
would
different
not
options
pose
that
a
you can
problem
play
at all,
around
but it
with.
was a
You
bit
can
of
do things
a
like
struggle at times, because
scale
the
and
resolution is
rotate
quite a
the
bit
image,
higher.
which can be pretty
And
helpful. Now,
you
there are
can
issues when you're
kind of
scaling
tell,
pixels. You generally don't want to go
you see this one. You can kind of tell that the font is quite a bit bigger, because this is the biggest font I can do from the embedded graphics. And yeah, it's just harder to drive. There are more pixels to work with. So I had to do some frame buffer shenanigans to make it work. And also, yeah, to get this frame rate to be decent. Because yeah, you do want to be smooth, but yeah, more pixels is more work with the same processor and the same amount of memory. And you see also it glitches from time to time a little bit. I'm not sure if I can do anything about that. Maybe I should synchronize something, but yeah, I'm not really an expert in this, but this kind of works. So let's have a look at the code, what that looks like, and what it took to get here.
You're going
so
to
before
a
we get
deeper
to
range
the
or a larger
code
range
itself,
of color values.
Let's talk a bit about the architecture.
The 565 is what we're
there are some
code,
nice aspects here, because what I ended up doing,
the prefix
is
0x
this,
is what we want to see, and again, that's how these
this
colors
controller
are
is
defined
totally
inside of the
independent
libraries, and that's what
the
we want.
others.
We're going to
So
leave
it will also
split
connect
rows,
to ESP
and what
now,
that means is in our code,
obviously,
it's going to give us individual rows,
but
and
it
then
will
it'll go
just
down to the next line.
yeah, receive
We're
the
not going
same
to worry about
command
trailing bits,
and
but
respond
the
accordingly.
two other
So
important
nor the
aspects here
controller
are
nor
going to
the
be the
car
block
are
size and then
aware
the byte
at all
order.
that this thing is there,
So
because it doesn't
the block
send at all.
size
It
for
only
us,
listens to
we're going to be using
commands.
16-bit, and that's going to give us
so that's pretty nice,
the
because you
code,
can
which
just
is 0x
anytime you can
0000. It's going to give us the
separate
appropriate
a
number
complex system
that
into
will represent the colors in our code. If we happen to go to 24-bit
it's a win.
or down to
so
8-bit,
yeah,
the 8-bit
for the
is
rest,
going to give us
this
the
thing
format of
works pretty much the
0x00.
same.
The
there was
24-bit
some
will give us 2 extra digits
inside
of each byte in the array.
I did
so
create
keep
the
in mind
one where we
that the
could
block
draw the
size
shapes
that
a
we're
few
going to be
episodes
using
back
for this image
on
and
this,
for probably
this same
most
controller.
images that you're going to come across.
But then I did
like
not have any kind of
the 16-bit block size, and the color will be the 565.
Tell that the drawing was pretty slow.
The last bit that I want to mention here before we actually preview this and convert it is the byte order.
Relatively smooth.
Now, this little endian and big
frame
endian,
buffers.
these
so a frame buffer is
are
basically
going to
a
change
piece of
the
memory
way
I
in which
reserve.
the colors are displayed on the screen.
And
so if you happen to convert an image and the red is purple,
embedded graphics
then
can draw
that
straight
typically means
into
that
that memory.
The byte order is
and
reversed. Now,
once
the
I'm
good
done
thing is
drawing
that
a
we
frame,
can actually
I copy the
affect
entire
that
frame
change
to the
directly
screen.
in the code.
And that's way more efficient.
So my suggestion is to
doing
leave
it
this
pixel by
option, the default option,
so
using little
that's
endian.
all
and then
very
what we're
nice,
going to do is
but
we'll talk about in the code
I don't have
what
enough
would
memory.
happen if the colors
Because
were swapped.
the resolution
There's
of
an
this
option
thing
to set
is
swap bytes using the again the ESPI library, which is included in
so
the
that's
stack.
and
by turning that on,
bytes per pixel,
you can change which one of these you would use. And again, I suggest that you use
so
the default.
that's
And if the colors happen to be
128,000
backwards,
pixels,
then you can go ahead
and so that
and swap
comes
it
close to the
now, I will
very
say
close
that
to
a
the
good
about 300
way to
kilobytes
sort of
of
test
memory you
this
have
is
free.
to
So
start
that's
by
all of
creating an image
So I just
in
can't do
just
it.
Paintbrush
If I,
or wherever you want.
If I create
make a bunch of different colors,
a frame buffer
reds,
of the whole
greens,
thing,
and blues,
I can do
change
it.
the
So
hue,
I have to
make them
then
lighter
not
or
use the
darker,
entire screen somehow,
and then bring that image in here,
which is kind of a
convert
pity
it to
because,
code,
yeah, it's
and
already
display it
small.
on your screen. Make sure that the colors
and
are
also,
correct. Make sure that
in this case,
the bytes aren't swapped, and
I
figure
also
out
want
what you
to
need
run
to
the
do to
whole
make your
Wi-Fi
code
stack,
work.
right? The
For this
ESP now
example, I've already
Rust
played
also
around with
drags
it.
and
I know
stuff.
that this should work.
So,
if it doesn't, then
that
we'll
was
address
not
that
an
problem.
option.
But this should be fine with these settings. 565.
So there
16-bit
was some
block
struggles
size,
there as well.
Prefix of 0x.
But
The
maybe
delimiter is a comma.
let's go
Again,
through
it's what
the
it's going to look
code
for in the arrays.
the
If you were
beginning.
using
Let me
something
switch
besides
off the
Arduino and you needed a
camera,
different
then we
delimiter,
see
you
all of
could
it.
include that here.
So,
But once we have all of the things set,
so
what we're going to do
the
is
graphics
show preview.
itself, I
Now,
just
if we were to
pretty
try to
much
save or
ported it
export
straight
this, it
from
exports as an XML
Volos
file. So all we're going
repository.
to do is we're going to
and
copy this.
that's actually
Now, again,
quite
it's important
nicely
to note
done. I mean,
that the
it's
preview
really
here
from basic, so
appears to
it
have
wasn't that hard to
transparency,
port.
but that's not the case because
primitives were a little bit
anytime we
different on
create a
Arduino,
sprite
but
or
not
we
that
display
much.
an image, it has to be
there are some
rectangular in
nice
nature.
touches
In this
here
case,
and
it's
there.
square,
Let me
240 by
show
240,
you.
but it's not going to be round. Now, I do know that the subscriber that sent this to me, Anthony, has a round display, a round LCD. So if there's extra information on the outside of it, it's probably not a problem. Most of the time, LCDs or screens will have a buffer range where you can display.
So because we are doing quite a lot of
values, the top left corner will still be 0, 0, and you kind of have to work within those constraints.
So we need
I'm
to
using
calculate
a square display, 320
angles
by 240,
and
so
location on screen.
It doesn't really
that's
matter to
not
me if it's
something
round or square, but we will talk about
my
ways in
controller
which
is
we can
particularly
address
good at to do really quickly.
So as we look
So
through
we
here,
are building
what you
up
see,
a
the code looks
table
very similar to what we got from image
all
to
the degrees
CPP.
0 to 360.
We've got 0, X,
and
F,
to
F, F,
record
that's
all
white.
the points on the
so
screen.
that top left corner, even though it looks transparent,
and then obviously
is white.
for both.
And then as we go down, we should see some zeros for black.
So yeah, we
calculate
all of those and
then there's some other colors
those
in here. And other colors typically are going to
seconds,
represent
maybe 2. So
again,
that's not nothing, but it's only on startup.
Values,
so after that, you have that table,
and then
you
for the most part, all the colors are either
go through
black,
the graphics pretty
white,
simply.
or red.
So
in this gauge, but
this
again,
is a totally separate repository. My plan was to
now, if you happen to make this grid, let's say in a spreadsheet in Excel.
It's not in there.
You wanted to manually build this
that was a bit of a disappointment because I
visually see what this looks like. So if we expand this,
but this is using the Extensa architecture, this controller. Yeah, we talked about it a little bit in the.
Then we could actually see this image take shape just.
But it's not an official target
these
of
are different.
LVM.
You know, these look different enough that when we
Expressive
scroll through the
made
code,
a fork for Extensa, so
I don't really, again, I don't recommend it if you're doing something smaller, like a 16 by 16 pixel sprite or 32 by 32.
And that's something you cannot do right now.
Then you can maybe
you
do this
can
manually, but there are so
combine
many tools out
different
there
architectures in the same project. That
really
works
don't
totally
need to go
fine,
through that process.
But not different tool chain.
All right, so that was quite a bit. Again, I'm not going to be using the LCD image converter, this download option.
I figured
we are going to
maybe
be focusing on the code that came directly out of the image to CPP website, which again, you can download, you
car
can
itself and the
run
controller.
It offline. I'm going to go ahead and close the image to CPP.
I didn't get
and
it
again,
to work.
we're using
so
Arduino
I separated them out.
2 bytes per pixel, 565.
And as I said before, the
identifier prefix, prefix here doesn't really matter. If we copy the entire code,
okay,
that does
so
you can see here that it takes the name of the file.
How does the
it,
drawing work? That's quite a bit more
in front of it.
complicated than I had anticipated. Because, as I said, I can't make a frame buffer,
I don't
so
really want to type all
I have
that every time
to do some
I'll simply call it speedo white or something like that.
Shenanigans.
Keeping in mind
what I'm doing
again,
is
as I mentioned,
actually I have
this
two
came
frame
from
buffers.
a subscriber. He sent me these images, so I am not going to share them because he did create them himself. I don't want to just freely share these out. But you can create something like this on your own. Again, in Paintbrush, you can do it. You could do it in any image software if you're using free software like GIMP or paint software like Photoshop. You could certainly create your own gauges. They could be square, they could be round, whatever you want. But just keep in mind that the size, the pixel
there are two gauges,
size, the
and
240
they have one frame buffer I use for
if you're
both.
making something that's a different
so what
size,
I'm doing is I create an empty frame buffer, a square one.
Otherwise,
I draw in the static data, so the outer ring and the dashes and everything.
Before I copy this code
and then
we're going to go into our Arduino sketch. This is
kind
a
of save that,
sketch.
And for every frame, what I do, I clear the inside, so I draw a smaller black circle inside,
the basics that
and then I draw whatever the frame wants. And because that outside part is for both the same,
do a project like this,
not actually in this drawing, but it is on mine.
It's very easy.
I can just reuse that frame buffer. And then try to tweak what I do, I create one. I have that one frame buffer where the
something like this, there was a lot of back and forth
has been drawn. I draw dynamically the inner frame, so the numbers
to me and to my
dial
the way that my brain works. So hopefully the way that I explain things here will
I do have to also rewrite
the
text on the outside because the dial passes over that text, so it will destroy it otherwise.
Correct me so that everybody has
and I
information.
Draw it in there,
but
flush it to the screen,
we're going to talk about
then clear out inner again, draw for the other gauge
into an Arduino sketch.
And flush that.
We're going to talk about how to display it, and then we'll get into the sprites.
That works reasonably well.
So the first thing I need to do with my sketch is I need to include my
create a second one for the inner part, so where
you are using another board,
where the I can't point to it now, but where the indicators are, so they're right there in the middle. So that has a separate buffer. So, but that one is small. So these two I can do, and that kind of works. So
it has an accelerometer, which I do plan on using later on.
That's
for other
quite
projects.
A lot of.
But in order to have all that in one package that already has an LCD display, you don't have to
I ended up creating the gauge because I gauge as a struct because I want to reuse that twice, right? So that I'm not creating two totally separate things that are very similar.
Go through the process of trying to make everything just work before you
start. I ended up using quite a bunch of
include M5 stack.h
generic const.
Now, I think at this point it's important to understand that
save memory mostly.
Whenever we include a library, the M5 stack.h for example, what we're doing is
I created a class dashboard
I need
which
this library because it contains all the little bits of code that I need to do things like display images on my LCD, to send text to my screen, to make the speaker beep, to access
that saves all
the
either the constants or just
to even access external.
This is the table I talked about before with all the angles.
In mind,
you put in
what we're going to be doing is we're going to be creating our own .h tabs inside of our sketch.
Is the outside
now the reason that we want to do this is because if we go back to the image to CPP,
N is where
the code for the 240 by 240
you can use those
array
to draw
is very long, right? So we've got 240 by 240
and
each
whole
pixel in that array. requires a single line inside of that array. So that means that we've got a
and
lot
that's
of
that.
and we don't want to just put that at the very top of
this part,
our program here, because then everything that's important
then,
to us in this program is going to be buried in the bottom. So the way that we do that is we make our own .h tab inside.
And the gauge,
the first thing that I'm going to do is I'm going to save this.
Has an initializer.
So inside of here, we need to find a location that you want to save
set line
the project.
1 and set line 2. So
and once we have that location, just name the sketch
in the middle. I kind
in this
of
case, I'm going to call this one.
Missed those. I didn't talk about them at all. But the focus is slightly off. But yeah, there are 2 lines of text in the middle of each. So for one, there is the speed actually, and all that says kilometers an hour, which makes no sense in this context. It's RPM actually. And here there is also a odometer that just yeah, keeps on counting. It doesn't persist it. That would be cool to find some persistence way. There are some nice grades. I mean, it's silly, but still. So it has some. But back to the code.
Add the .h,
so every gauge has a set line 1,
you can
set
see now
line
we've
2,
got this
set
speedo.h tab.
So that's the actual value.
What we need to do inside the top of our main sketch is we say
that has
this time we're going to put it in quotes, and I'll explain why in just a second. But then include speedo.h
relative to the max value, which is a constant. It's now at about 1200.
When we look at these .h's,
so that's about
essentially when you put it in these
can do
brackets,
a little bit more.
what you're getting is an external library. This tells the code we're looking somewhere else for this. When we put it in quotes, the .h is going to be internal to
I have to take into consideration
that in the
that
same folder structure. It's not
I don't
in the
get a
libraries
new
folder
speed
structure
reading
inside of your Arduino IDE.
frame,
so this
right?
gives us the
because
ability
I just
to create other tabs,
measure whenever
speedo.h,
the
and then we can
passes
include
the
whatever
whole
code we
sensor
want
on
in
the
there,
wheel.
and then instantly we'll have it available.
So I just get pulses, right?
So
with
there is another thing that we need to
differing,
do when you're using the
times
TFT
between
ESPI
them. So
library.
if I do that,
or in this case, the M5 stack
just
library.
jumps
What
around
I found,
because
at least
then,
from just some playing around, is that
yeah,
inside of each of these tabs, it wanted to
so
also
that's a little bit
include
more complicated
the M5
as well,
stack
because
library or ESPI
I get those
or whatever
pulses
you're
and
using.
then I just
And I think the reason is because it
we'll
needs to
kind
be
of
able to
need to,
call some of those different functions.
smooth out
so
that movement.
just putting that, in this case, M5
also
stack.h
to balance
at the very
a little bit
top,
how often
we'll make sure that our code runs
I
smoothly.
actually send a
Now
pulse.
that we have that, I'm going to
Because
go
if the
back
RPM
to
is
my
high,
website.
it's too
image
high
to
for the
CPP.
car to send
I'm going to copy
a
the
packet
code,
every
so
single
copy
time.
that output.
So it will
And then back
send
inside of my
the
Arduino
last
program, I am going to
timings
paste it.
between the pulses.
Now,
That's
when this
basically what it
happens,
does. And
when
the total number
specifically
of
you're
pulses.
using
So it will
image to
never
CPP,
miss
there is some
actual
extra
value. So the
information
odometer
in
will still
here that
remain
we actually
correct.
don't need. So at the very bottom of this,
yeah, and if I
can
draw
see that
static,
it
so
puts
that's the part that I mentioned
EPDM
before,
bitmap all
that I will
array
draw once,
length 1,
and because I
and then
don't
it gives
clear
you
an
this
entire
call
frame
for
buffer,
the
I never
array.
need to do it again.
Now the reason that you might want
So
to
this
do
frame
this
buffer
is if you
is the one that's shared between
multiple
the gauges.
images
It's the same
in the
one.
image to CPP.
And
Now
it
if
has,
that was the
fixed
case,
size.
what would end up happening
So
is
I
it would
draw
hard code
some
in
arcs, so
the
that's
array
basically those
values, and
outer
that might be a
circles.
good way for
They're
you
not
to call
totally
those
circles
different
because they
arrays.
don't go
For
all
us,
the way around.
we're
but
going to be
they're
putting
arcs.
each gauge
So
or
they
each
go,
element onto its own tab or in its own .h file.
From
So I don't need to do that.
120 and then
Another thing that we need to talk about
degrees. So
is
there,
going to
most of them
be
are 300
things
degrees,
like
so that's nearly a circle.
the name,
and
the
then
units,
I draw like
the variable
text, so
declaration,
the numbers,
and
that
also
kind of
this
stuff.
prog mem. Now, this
and
right
to
here,
clear the
again,
inner
it's going to
side,
be
so
very
where
dependent
the
on
moving
the board that
gauges
you're
I
using
have,
and the memory that you
I
have
just
available.
basically draw
Essentially
a
what
black
that is
circle in the
doing
middle of
is
it.
it's pushing this array
Then the dynamic one,
into
so
the
that
program
gets
memory.
called over and over again.
Now, this is where you start to get into a little bit of trouble with different boards, like
there I actually,
on Arduino
this
Uno.
was kind of
This
messy
would
to get
definitely
right, but,
overrun the memory on an Uno. You probably don't
calculate
have
the
enough
angle,
to do a 240 by 240 array,
and then
and you'd have to go much smaller.
I create an indent
With the M5 stack, I don't actually need to declare that it's going into program memory.
Yeah.
Now, again, if you're using a lot
got
of
in some
large
really
full-screen,
weird stuff here and there.
16-bit color depth images,
the
then you might
of
actually need to enable the PS RAM or expand it and put it in there. But
even if I never
for
ran
this
it,
example, it actually works fine with
mess it totally up.
multiple .h's, so I'm not going to worry about declaring program memory. Again, memory management
it would compile,
is an important topic.
And it would link,
it's something
and it would
that you
upload
should
it,
look
but the screen
into.
just
I
wouldn't
don't
work.
really have
So
a full grasp on all the
something
memory
happens in the
management
linker
aspects, so
that
I don't
changes
want
it,
to talk about that. So I'm going to leave it at that and just note that depending on the board that you're using, you might run out of room depending on the size of your image. So what I want to do is I want to rename this because I don't want to type in EPD underscore bitmap underscore Mercury. I don't want to type all that in.
Yeah, it's not really complicated.
So
but
what I'm going to just call this is
road to get
Speedo
there
WHT. So Speedo white.
Finally,
this
here
is the background, but I don't really need to worry about calling it the background. When we get to creating our sprites,
this is the
we'll call or we'll create a sprite that is the background image.
Again, we're using Embassy.
Speedo,
we're using
a
bunch of Embassy tasks.
Those can be called depending on what the user selects.
We have the graphics task,
kind of
so
more of a
keeps
long-term goal. In this video, we're only going to be talking about the speedo and the needle for the speedo. But just keep in mind that the image that gets pushed into the sprite could be this image or it could be another image, depending on what the user selects, and that's why it gives us so much flexibility.
Updating the drawing.
All right,
and
so
there's the startup sequence that gives
and
that nice
the main program, the image-based gauge.
Sweep
I'm going to do a quick save
of the dials.
And now what we've done is we've called
we can have a look at that one,
which gives us access to do things like
so,
use sprites if we want to, but more importantly, in this first example, we're
I give it the moment to
the M5.LCD to push to the screen.
Basically,
if you're using another display, another board, again, there are different ways that you need to do that. You need to include different libraries. You might need to use TFT,
if the car would send
draw circle, those kinds of things are different depending on the libraries
and
that
motor
you're using.
RPM.
So M5
motor
stack is going
RPM
to give us
for me
access
now
to
is
all
the
that.
rear wheel, RPM
Include
is the front
speedo.h is
wheel.
going to give us access to use speedo WHT.
Indicate
we do need to remember that it's
what the motor does and this is what the wheel
pixels.
does. So it should be similar.
A lot of times you might see examples where the pixel values are actually coded in here as well, and then you can access those global variables. We're not going to be doing that. I'm going to hard code those values in. Simply because I know that you might be playing around with different image sizes.
1200 RPM. It can do
Again, we're not going to be doing anything with sprites, but I'm going to go ahead and put a comment in here.
Then setting it back to 0.
We're going to declare sprites for background
because if you do that first, then
so that's going to happen here before our setup. And then we're going to go into setup, and we need to do all of our standard stuff. Now, for me, with the M5 stack, I need to do M5.begin. So that will start the M5 stack. We're going to do M5 stack power.begin. Again, allow it to use the battery, so we don't have to be tethered to a USB
plus
cable.
the subscriber.
And then I'm going to fill the screen.
I also
so
do a
M5.LCD fill
that's
screen.
for the value update, so that's a separate task.
TFT underscore white. I could also just type in white.
Some constants.
Again, these are declared various different ways depending on the libraries that you're accessing.
The dashboard.
The TFT underscore white is part of the ILI library for the display.
And then we enter
the
loop.
other just white is declared in another library. But again,
redraw it.
Automatically has access to all those. If you're using a specific TFT library, then it's good for you to go into that code.
Yeah, so I'll get to this part again because that's about
file
internal
that you can go into, and you can just look at those declarations with
if there is a
notepad
message,
or
read that
code,
message.
A code IDE. Not necessarily the Arduino one, but if you've got
depending on motor
Visual
RPMs
Studio or something on your computer,
right
you can
gauge
open those files up.
And
okay, so now in our setup, what we've done is we've essentially started the M5. We've said that we can use power. We've filled the screen with white. Remember, in this example, we're not talking about sprites yet.
So that's
all
something
we're doing
I had to
is
add
we're going to be
car
displaying it on the screen. So it's fairly simple for us to display the image. There's a command called push image. Now, again, you might be thinking to yourself,
central part
why didn't we just load it onto the SD card? I mentioned earlier on that
not that interesting.
that is a different place in memory inside of the device. In this case, the M5 stack.
Indicator.
And the amount of time it takes to bring the image off the SD card and display it on the screen, it's just, it takes too much time for something that we're constantly going to be updating with a speedo needle or something like that. And on top of that, at least I haven't found a way with this library to take that image, a PNG with transparency
a signal
and push it into a sprite. Now, I haven't found a way to do it.
I used to communicate with a graphics task, because actually
just for me it was much easier to use this byte.
A little bit tricky.
So we're going to use a byte array, and we're going to say m5.lcd.push image. Now, when we have a push image, there are a couple of things that it needs. Now, if you actually go into the library, and I'm going to go ahead and open this up.
Things like back pressure.
So if you go into the library, in my case, m5 stack.h, which brings in LCD, in this case, the LCD values. Again, they're coming from the different
because
LCD
whenever I update the value,
as we look through here, you'll notice that we don't see a push image.
But it's a little bit too far in the weeds, so
when you have the LCD values, we've got drawing pixels,
but yeah,
we've got draw image, draw circle,
think
and so on.
All in
and
all,
we've got these things.
I am pretty much done with the car now. There are I have some ideas, like to see if I can create a sort of traction control by measuring the difference between the drive wheels and the front wheels, and then just reduce the engine power so it won't spin out. Might be cool, but I think right now with a single magnet Hall sensor the resolution is simply not there. Saving the odometer to the flash is also an interesting thing, maybe, but it gets too complicated, and I prefer to do the live coding I did before, but for this it's too much. I can't do all of that. So yeah, let me know what you would like to see. I think I'll do some smaller things now. I want to work with LoRa, so to do the long distance wireless stuff, maybe some I2C or I2S connectors, that kind of stuff. But yeah, I'm gonna leave it here. Thank you for hanging out, and talk to you soon.